back to my YouTube channel, in which I've created the playlist of data science covering the basic and advanced concepts. So my next topic is data preparation phase to model the data. Topics which we are going to cover are how to partition the data, how to balance training data set, how to construct CRAT decision tree, how to build random forest, how to build C5.0 decision trees using Python. Now, introduction part. The ultimate goal of data preparation phase is to transform raw data into a format that allows machine learning models to learn patterns effectively. It ensures a model is trained on high quality data that is clean, well structured, and representative of real world conditions. So, what is data partition? Partitioning the data into training and testing sets is a fundamental step in data science to evaluate machine learning models effectively. Proper partitioning helps ensure that the model generalizes well to unseen data and avoids overfitting. Now, in Python, the most common way to partition data is using the train test split function from the scikit library, which splits the dataset randomly. Now, what is cross-validation split? Cross-validation is a technique where data is split into multiple parts and models are trained and tested multiple times on different subsets of the data. This helps to access the model's generalization ability more effectively. Now you can perform cross-validation in Python using the following code. Next is balancing. What is balancing? Balancing the training dataset is a crucial step in data pre-processing when dealing with imbalanced data. An imbalanced dataset can lead to a model that is biased towards the majority class, which can negatively impact the performance of classification models, particularly in terms of prediction accuracy for the minority class. What are the techniques? First is resampling techniques, oversampling, undersampling. Second is synthetic data generation. Third is using class weights. Fourth is anomaly detection models. Now, balancing the data in Python. Random oversampling. In Python, you can use the imbalanced learn library to perform random oversampling. Second is random undersampling. This technique removes instances from the majority class. Third is synthetic minority oversampling technique. It is a more sophisticated oversampling technique that generates synthetic examples for the minority class. Now, what is CRAT decision tree? A CRAT decision tree is a popular machine learning algorithm used for both classification and regression tasks. It belongs to the family of decision tree algorithm and is a type of supervised learning technique that splits data into subsets based on different criteria, ultimately leading to decision tree prediction. And these are the characteristics of decision tree, that is binary split, tree structure, recursive process. Now, what are the key concepts involved in decision tree and CRAT decision tree? First is splitting criteria. For classification, the primary splitting criteria is gini impurity, but sometimes entropy can also be used. Gini impurity measures the degree of impurity of a node. A lower Gini impurity indicates that the node is purer. Entropy is another measure of impurity used in the decision trees like ID3, C4.5. For regression, the primary criterion is mean squared error or variance within each subset. The algorithm will aim to minimize the variance in each of the resulting subsets. Next is stopping condition, maximum depth. The maximum allowable depth of the tree, limiting the depth helps prevent overfitting. Second is minimum samples per split. The minimum number of samples required to make a split. A high value can prevent overfitting by avoiding small leaf nodes. Third is minimum samples per leaf. The minimum number of samples required at a leaf node. This ensures the model does not overfit to noise in the data. CRAT is widely used due to its simplicity, interpretability, and flexibility. It serves as a foundational technique in machine learning and can be extended with techniques like random forest and gradient boosting. What are the steps involved for building C5.0 decision trees in Python? First, install necessary libraries. Second, import libraries. For example, import pandas SPD. Load dataset. You can use any dataset such as iris or dynamic. Then split the data into training and testing sets using split function. And then train the C5.0 decision tree. Then make predictions on your model. And then evaluate the model. Then next, what are the steps involved for building random forest in Python? First, install necessary libraries. Second, import libraries. Third, load dataset. Fourth, split the data into training and testing set. Fifth, train the C5.0 decision tree. And then make predictions and at last evaluate the model. Now, let's move to the coding part. I have given the code to demonstrate how to construct CRAT decision tree using Python. First, import necessary libraries and packages like NumPy SPD, Pandas SPD, NumPy SNP, and train test split, decision tree classifier, plot tree, load iris, PLT, accuracy score. In order to read data in form of iris, I am using load iris and storing the data in data variable. In order to show the features, I am using the format data.data. In order to show the target labels, I am using the format data.target. In order to split data into training and testing sets, I am using split function and showing the result in respective parameters. And then in order to initialize and train the decision tree classifier, I am using decision tree classifier function in which I am passing 42 parameters by using random state. In order to train the model on training data, I am using classify.fit method in which I am passing parameter x train, y train. In order to predict the target labels on the test set, I am using classify.predict method in which I am passing x-test parameter. In order to evaluate the model performance using accuracy, I am using accuracy score method in which I am providing the y-test and y-prepared parameters. In order to visualize the trained decision tree, I am using figure method and plot tree method. And at last, I'm using PLT title to show CRA decision tree title and show method to show our decision tree. Thanks for listening me patiently. Have a nice day ahead.